as I was saying, the tips: identify where these devices are located in your school. So maybe in the afternoon, we will do a tour of our computer labs. We'll do a tour. And in fact, I will do a tour of the computer lab in Lagos campus. Since I'm here in Lagos campus, we'll set up a camera there, and I'll go to the server room. We'll set up a camera in the server room. Then we can set up the Zoom, connect to it. Then I can use that point to explain certain things to. Very, very important. If you don't understand this level of aggregation, segmentation of the network, I'm telling you, when there is a network breakdown, you will not know where to go. So on this page that you see like this, it means the router will be the one that will give IP addresses to all the devices through the switch. So the switch is a dummy. Take note of what I said. The switch is what? A dummy. It is not playing any intelligent role of assigning IP addresses, but it is actually playing a role of being able to connect all the system to the router so that every system can pick IP addresses. So the IP comes directly from this router and straight to the PCs, but is passing through the switch. And the switch is not going to make mistake. Once the IP is coming from the router, the switch is not going to give an IP that is meant for another person to another. So everything is going to be done awry. Is that clear? Good. So we proceed. I'm going to the next slide now. Now, if you look at this slide, I am asking a question. What is the characteristics of a LAN? Now, this diagram clearly explains that to us. Now, look at this. First of all, look at the structure. This structure explains what I explained in the previous slide, but let me take time to explain that again. Now, look at this. We have up here, we have the internet. You see that the internet on blue? Internet at the first up. I'm coming from up. The internet is on blue. Next to it is the router. That's the router that connects you to the internet. Then next to it is the switch. Then next to it are our PCs connected to the switch. The same order that I explained to us before. Now, what is the characteristics? One, the LAN uses cables. It uses cables. That's one characteristic. No wireless, cables. Number two, it is faster or fast and stable. It is fast and stable. Why? On a port, these network ports that you see, they are rated as 10, 100, 1000 for now. Let's stop there. 10 means 10 Mbps. 100 Mbps. 1000, 1 gig, 1 gigabit per second. So when there is a connection between a computer and a switch, depending on what that switch is rated, is it a fast Ethernet switch or a gigabit switch? If it is a gigabit switch and the port of the computer also is gigabit, that means there is a 1 gig connection between the switch and the system. So it will make the data transfer to be stable. It will not break. It will make it fast. Then there will be no interference because frequency is not involved. The cables inside, the interference in the cable have been taken care of. That is why the cable is called twisted pair, because they are twisted. They are twisted so as to avoid the interference that happens in cable that is called crosstalk. Crosstalk takes place in cable, but the twisting makes that crosstalk to be avoided. So this arrangement is best for computer labs or CBT centers, offices, and what? Servers. Computer lab, offices, and what? Servers. So let's take note of that. So next slide. If you think I am too fast, you can stop me so that, or there is anything you want me to explain. If you have a question, you can stop me so that I explain it quickly. Then we go forward. Next slide. Now, what is a WLAN? We have dealt with LAN. And based on the LAN we dealt with, we now said that you must take note that LAN uses cables, nothing more, no more, no less, uses cables. Uses cables to connect. And I gave you the structure from the device, the PC to the switch, from the switch to the router. If internet is needed or if we need dynamic IP. If we don't need dynamic IP and we're not connecting to the internet, it is just the computers and the switch that is needed. The router is not necessary. The router is not necessary. Then in that case, it means you must apply static IP from one system to the other. It has its own challenge doing that. You must put IP on all the systems one by one. So step 4, we're looking at WLAN. What is WLAN? WLAN stands for Wireless Local Area Network. Is a LAN that uses Wi-Fi instead of cables. Is that simple to digest? Yes. LAN uses cables, but now WLAN. So it is still a LAN. It is still a local area network. It's still the same thing of data sharing. It's still the same thing, informations are shared. It's still the same thing, IP addresses will be involved. It's still the same thing of bringing connectivity to the same space where all devices are. But the difference now is that cables are not involved. We are using radio signals, wireless signals. So devices connect wirelessly using radio signals. That is a LAN. Now, you will understand a lot as we go through this segment of the slide. So, if you look at the slide in our front and look at the diagram, you will see that all the devices are having connection, but they have the symbol of wireless connected to all of them. So what are the components we have in the LAN? We have the router, we have the access points and the wireless devices. Now, take note, does it mean in a WLAN switches are not involved? Oh no, switches can be involved. Yes, we can have a LAN structure that has switches. I'm going to explain. So, but in a simple explanation, from our tablets, our phones, our laptops, they connect straight to our wireless access point. Then our wireless access point, if it's connected to the router, immediately it connects to the network and browsing starts. Now, if you look at this structure we have down here, in this middle here, we can actually put in a switch between the router and the access points. We can bring in a switch. Let's say we have 30 classrooms, 20 classrooms, 18 classrooms, 15 classrooms, or different offices. I want to put access point in each of those places. You will necessarily not get a router that will have such number of ports for you to be able to connect from the router straight to the access point. That's where the switch will come in. So the same way, the switch will still be a dummy in between the router and the access point. So you will now get a switch in between and put it here. Then it will now be from your access, from the devices to the access point, from the access point to the switch, from the switch to the router. Then the router will now connect those devices to the internet. So what's the explanation of this scenario? Access points send Wi-Fi signals, devices connect without cables to those access points, and then the access point connects you to the router by giving you IP addresses, and the device is connected to the internet. Or if there is a server, it connects you to the server there. Now, though cables are not involved, but take note, signal strength affects what? Performance. Signal strength. So the closer you are to the access point, the better. The further you are from the access point, the worse your signal will be. So if you are in a classroom or in a hall, and there's an access point in the front of that hall, the people who are at the front of the hall will be the people who will get the best of the access point. And all the people who are at the back, as you keep going back, the signal will be getting degraded. And eventually to a point, it becomes faded and become weak. Connection will not be able to take place. Do you know that even in cables, it's the same thing? For our Ethernet cable, there's a maximum distance your cable is expected. Theoretically, they said 100 meters. But from practice, from certain practice that I've done in the field, as you are going above 50 meters, you begin to have problem. And I think the reason is this. We are supposed to have a cable that is pure copper. But most times, people who sell, or will I say manufacturer who sell, most times if the cable is passed through a test, it will be difficult for you to see a cable that is pure copper. And if it is not pure copper, once the length is increasing, impurities that are on that cable will not allow the continuity to take place. Therefore, signal will be degraded above 50. So I won't advise you to go above 50 meters. Except maybe you don't have an option. You have to go above 50 meters, then you can go up to 60. Or option 2, use a fiber cable. Use a fiber. Just go fiber. Then you can have peace. But if you didn't go fiber and you connect above 50 meters, that link might be failing. That link might fail. So we proceed. Next slide. Now, what is the characteristics of a wireless LAN? One, it is easy to move around. That's true. Very easy. Very easy. I can connect my system. As I'm having this class now, I'm actually connected to an access point via wireless. I can move, I can pick my system in my hand and be moving across the corridor and still be having this meeting ongoing and still be training. But if a cable were to be connected, that means I must be sure that I'm close to that switch, because if I move around, the cable might be disconnected and I will be disconnected from the network. So it is easy to move around, and we can easily remove an access point from this place now and take it to a new place immediately and set up a connection. It is not that easy with cable. So easy to move around. Not just that, it is easy and fast to set up. I can just come to a class, just draw one cable, plug an access point to it, and drop it. If we have 30 students in that class, that means I am sure I've connected 30 people. If it were to be cable, I have to run 30 different cables. I will crimp both ends. It will take time to set up. And most times, it will keep the environment very, very untidy. Then, wireless also requires strong security. That is password. Otherwise, it will be open and people will see it. That is one disadvantage of wireless over cable. Because if your network is cabled, it means for anyone to have access, he must physically have access to the server room and plug a cable. Then, before he can do his exploit. But if it is wireless, even someone, we call them people behind the wall, somebody behind your fence can come and tap from your wall wireless. So that's why strong security is required in wireless. So that's the characteristics. of wireless if we compare it with our cable network. Now, we're looking at LAN versus WLAN in comparison. Features. We're picking the features. We're picking for LAN and WLAN. Features, if we're looking at connection, LAN require cable. Wireless require radio signal. That's why we call it wireless radio signals. In terms of speed, LAN is faster and WLAN is slower. In terms of stability, LAN is very, very stable. Then WLAN can fluctuate. I will tell us something there, why fluctuation takes place. In terms of security, security for LAN is very high because, as I told you just now, it means it needs physical intrusion for a cable to be connected. While WLAN needs to be protected, you must put in firewalls, put in rules, put in password. Otherwise, everybody will have access. Then, where it can be used, best used, LAN best used in labs and offices because it's not very easy to use it across the corridor. You can't use it in an empty premises, empty compound, a hall. Not very easy for you to use like that in a hall. But for WLAN, you can use it among staff, among students in a hall and all that. Very easy connection can take place. Now, discussion. I want to give you 5 minutes to discuss where should LAN be used in our schools and where should WLAN be used in our school. If you have an answer, because I don't want to be the only one talking, if you have an answer, I want you to do that by raise of hand while I stop sharing my screen now. I'm seeing somebody standing behind me. Is that Mr. Macaulay? Wearing blue. Okay, that's your vice principal. Yes, okay, you are hiding behind the pillar. I will still see you. You are going. That's Mr. Lawrence. I'm seeing him now. He's running away. Hope he was not disturbing our class. Hope he was not disturbing our
he's
class.
part of the training. He's just in attendance.
Principal message to me now that should come.
Okay. You are free. Thank you.
Principal called said that.
Yes, I said you are free to go. Bye-bye. Bye-bye. Safe journey.
Okay, thank you.
Yes, so.
There are other videos. When did you know the video?
So, where should LAN be used?
Hello, sir.
In our schools.
Hello, sir.
Yes, I can hear you.
Yes, sir. Yes.
No, you will introduce yourself. Tell us your name. Tell us your campus.
This is Mr. Macaulay, sir.
Tell us your campus. You are not audible enough.
Okay, Mr. Macaulay, Calabar campus, sir.
Okay.
Mr. Macaulay, Calabar campus. Yes, sir.
Yes, go ahead.
We can use LAN in the school block because of the proximity to each classes. We can use LAN because it's faster. Then LAN to the admin block. We cannot deploy wireless LAN for that purpose. And it depends where the server is. So if we take the server to be at the ICT at the school block, then we can implement wireless LAN. Thank you,
yes, another understanding. I need a different. If nobody is talking or nobody is raising hand, I can call. I'm free to call now. I can't see hand up. Yes, Mr. Efe from Delta Campus.
Good morning, sir. Good morning, everyone. My name is Efe from Delta Campus. For LAN, it's good we use it in the ICT lab where we need stable connection, and also in the e-library where students can connect with their laptop, and then we need a stable connection for a research. But in places like central staff room, when staff goes in and come out, they connect, they go to class and return, we can use wireless LAN so that with their mobile phone, with their laptop, they can connect and disconnect at any time. Then we can also use wireless in our reception, in our conference room, where we usually have meeting or maybe conferences. We can use wireless LAN in such a place. Then we can also use wireless LAN in location close to staff quarters, because you cannot run cables to each of the staff quarter, maybe their room. So in that case, you just position an access point where people from the quarter or people from those locations can just connect with wireless, and it will be profitable. Thank you, sir. I also have a question when the time comes. Thank you, sir.
Okay, yes. I think this one you nailed it. It's as if you entered my heart. And when did you spy me?
No, no, sir. Actually, no, in mentorship, when you have interacted with somebody over and over, the person gradually become like that person. That's why I see us talk like GS. If you listen to some pastors, you wonder, is it GS that is talking? Like my principal and I talk almost exactly like the GS because of that. I don't know how we call it, whether there's fusion. Is normal in life, sir. You have,
Okay, so that's why you just spied my heart.
yes, sir.
Okay, you nailed it. So let's take note. And please, at the end of this training, I want you to go and implement. As he said, we will use LAN, not we can, we must compulsorily in all our computer labs. We're going to run LAN. LAN all through, connect all the systems via LAN. If you have an e-library, just as he mentioned, we'll run LAN there. Then all our classes we can do a WLAN to those places, drop access point in each of those classes, because it will not be easy. We have attempted running LAN in our classes before, but we discovered it became counterproductive because the students are in the class, they destroy those cables and they destroy those connections because they use the class every day. So LAN is not going to be very convenient in the classroom because the children are there every day. And as he said, in the staff quarters, you know, you will not be able to run cables to the houses of every staff quarter. So we build an access point. You get to a staff quarter, you drop an access point somewhere central in the in those staff lodge, and it will get to everyone. We can put 2, 3, or 4 depending on the size of the quarter. 2, 3, or 4 access point, and everybody will have access to it. So that means we already know what to do. The end of this training, we must begin to implement. Now, Mr. Efe, you say you have a question. Why not we address it before we move forward?
Thank you very much, sir. When you were talking about in that diagram, that should be slide 3, where you talk about the port of.
Can you be a bit more audible?
Yes, sir. I said when you were talking about the connection between the switch and system, you talk about the connection, you were talking about gigabytes and the port of those switch. So I want to ask, for if a particular, this, maybe I have a switch and I have another switch, what should we really put in consideration so that there'll be smooth transfer of data? Should I consider, oh, this port is so port switch? If I'm connected to another switch, it must be the same, so that that transfer, for example, like you said, if there's going to be a switch in between a router and another switch, what should we consider, and what are the things we look at in terms of gigabyte. You mentioned something like that, port connection.
Hmm. Hmm. This question is germane, and I will call it a jam question in networking, but it is a question or an understanding or a thought that is widely overlooked. Widely overlooked. I would what do I say? I would have loved to practically demonstrate that, so that I don't want to just answer the question. I don't just want to answer the question without giving pure or practical illustration. So I'm trying to see whether I will launch the whiteboard on this on the Zoom, so that I don't know. Are you seeing my whiteboard? Is it
It's loading.
trying to load?
Yes, it's loading.
Still loading, sir.
It's up now.
Can you see it?
Yes, sir.
Yes, sir, it's loading.
Okay. Uh, has it loaded or is still reloading?
It's loading. It's loaded.
Showing error.
Is it showing error?
No, we can see it.
Okay, you can see it.
Yes, sir.
Ready now.
Okay. Now, my drawing is awful, so don't mind it. But I want you to just have understanding. Okay, are you there? Can you see my screen?
Yes, sir.
I'm going to explain what I want, what I'm drawing. Okay, so hold on. So let's say this one is a server. A server. Then let's see, this is a router. Okay, there's a connection between this. Now, can we all see my screen?
Yes, sir.
I have 1, I have 2, I have 3, I have number 4 item on the screen. So let's say number 1 is a device, number 2 is a device, number 3 is a device, number 4 is a device. And I'm painting this scenario to answer his question and to tell us certain things that we must understand. Now, let's say there's a server also in this place, and this server is hosting an application where students will connect. So, at this point here, let's say we have this is a classroom block. This point, you see this circle that I draw now is a classroom block. And we have different classrooms. So I will connect different access points to different classes, different APs to different classes, like this to different classes. So this is a switch here. This is a switch. This another switch. His question is asking that switch number 1 is connected to switch number 2. And switch number 2 is connected to the router. The router has connection to the server. What kind of switch should switch number 2 be? Because it is switch number 2 that is feeding switch 1. Mr. Ife, did I get your question?
Yes, sir.
In terms of traffic. Now pay attention. We are going to come across a module that is on bandwidth later. But take note of this. If the connection that is coming from this router port here to this switch here, if this port and this port, this is a gigabit port, this is a gigabit port, that means on this router, it can give you 1000 Mbps. On this switch, it can also give you 1000 Mbps. So the traffic from here to here will deliver 1 gig, 1 GB, 1 gig. Are you following? Now, the moment the traffic lands here, if the connection from here to this point is also 1 gig, that means you can expect a 1 gig throughput to take place between switch 1 and switch 2. So you can expect a 1 gig traffic to flow through. But let's say you now have a TP-Link switch, because at times people don't consider this. You have MikroTik switch, you have Cisco switch, you have TP-Link, you have D-Link. And there is a problem. You just pick one switch and connect. This switch number 2 that you connected to the router port here is 1 gig. But if this switch is fast Ethernet, this one that is number 2, everything you have here become 100 Mbps. If this switch is 1 gig, this one here that is here, what the traffic that will come here cannot be 1 gig, is 100 Mbps. So between the number 1 and number 3, if you have a 100 Mbps switch in between, that means you have degraded the traffic by yourself. You degraded the network by yourself. You have you downgraded the network by yourself. So what should now be the order? It means the gigabit switch should come first before the fast Ethernet switch. I don't know whether I'm communicating.
Yes, sir.
Hello, everyone in the house. Are you hearing what I'm saying?
Yes, sir.
Good. So the order must be that from this port of the router, 1 gig, you must also maintain a 1 gig traffic and also maintain a 1 gig traffic. But to our own advantage, some of our routers and switches also have the fiber ports that gives you traffic of up to 10 gig if you are using the switch that has a SFP plus. That means you can have a 10 gig traffic between this router and this switch, 10 gig. Because take note of this, look at this carefully. Let's say I have this switch is gigabit, I have another switch gigabit, and I have 10 access points connected to this switch. All these 10 access points are going to be sharing 1 gig traffic, because whatever is coming from the router is no more than 1 gig. Whatever is coming from this router to reach here is no more than 1 gig. And take note, there will be losses. There will be losses at the ports, the port of connection. So at the end of the day, what we actually land this switch will not be up to 1 gig because of losses. So, but what all the access points that are connected here will be sharing is that same 1 gig traffic that is coming from this router. At the end of the day, from here to here, it can be more than 1 gig because whatever comes from here was 1 gig. So, and at the end of the day, before it left here, come to this point, whatever is left that all these access points will share. I hope I'm communicating.
Yes, sir.
Hello, I hope I'm communicating.
Yes, sir.
So, now we had a scenario in Port Harcourt campus where in the classroom, they had access point in every class. And the way the network was connected, they connected from a router to a switch here. They connected some access point to that switch, and from this switch to another switch, and connected some access point to that switch, and I think to another switch. So when we're troubleshooting, I now say, hello, anybody asking a question?
Yes, sir.
Yes.
We get the illustration. Hello?
I can hear you. Go straight to the question.
It's not the question. You know, you are talking, you drew some diagrams on the screen and you are
Yes.
making some questions.
Yes.
Your movement is not showing on the screen.
My what?
The movement, the movement.
Okay. The movement of my.
Your cursor is not showing.
Oh, okay. So I'm now going to explain better because maybe the whiteboard, I will explain better. So I get you now. Now, this is what I was saying. In our campus, can you see number 3? Number 3 device. Can you see number 3 device? The device I named number 3.
That's router.
Yes, router. They have a router on the network. This router. Then they have this server. You can see this server number 4.
Yes, sir.
Good. Now they have this number 2. Can you see number 2 here? This number 2.
Yes, sir.
Is a switch. They have this number 1. Can you see number 1?
That's another switch.
Another switch. Then I think they had another switch after number 1. Let's say towards this side, there is another switch here. Assuming. Let's assume there's another switch here. Are you following?
Yes, sir.
Good. Now go back. The connection from number 3, which is router, they connected from number 3 to number 2. That's a switch. Are you following?
Yes, sir.
So some access points were connected to this number 2. So some access points were connected to number 2 to some classes. Are you following?
Yes, sir.
Then they connected from number 2 here to number 1. That's to extend connection from switch number 2 to switch number 1. And also connected some access point to that switch. I hope the picture is clear now.
Yes, sir.
Now, what was the issue is that all the people connected to number 2, their traffic will be faster. Are you getting my point?
Yes, sir. What's that? Why?
Good, because number 2 is the one directly connected to the router. First,
Okay, sir.
is the first person you will reach. So, it is called a hub.
So let me think for nothing. Yes.
Are we following? Hello? Hello? Can anyone hear me?
Yes, sir, I can hear you.
Good. So now what I told you, I now told them to do is this. I said, this switch number 1 that is here, I said, go and remove it. I said, find a way of moving all the access points that are into it and bring them to this switch number 2 directly. If it was possible. He did that. The traffic, the speed increased. But there's no crime, actually, if you leave it like this. But it's just that switch number 2, participant or devices connected to switch number 2 will be faster than the devices connected to switch number 1. And that is because of that hop from one to the other. Now, that happened in Port Harcourt. So the moment they brought all the devices to this, the situation drastically improved. The traffic improved, because that means we sat down, we saw the situation of the network, and we optimized it. Now, but there are cases whereby this switch here will not have all the ports you need. Therefore, you might still need another switch to come in. Then in that case, you don't have an option. So you still have to connect it. But you must be sure switch number 2 should either be of a higher capacity than switch number 1, or worst case scenario, both of them should be at par. Switch number 1 should not be higher than switch number 2. I don't know whether you understand what I'm saying. I am drawing my ear if you can see me. Switch number 1 should not be higher than switch number 2, because switch number 2 is the one feeding number 1. So switch number 2 must be higher, or both of them at worst must be at par. In terms of, switch has CPU, switch has RAM, it has the port, the speed of the port, everything. Switch number 2 must be higher than switch number 1. Is that taken? Hello? Mr. Efe, did I answer your question?
Yes, sir. Very clearly, sir. Thank you, sir.
So now I've closed the whiteboard. So I want to go back to our slide now, so that so we should be able to understand that we'll do a tour and look at our lab. So I'm going to the next slide. So we have cases whereby we combine LAN and WLAN. We have that in our school. So we have some play. I think in Delta campus, in your lab, where you have all the computer connected with cable, you drop some access point in that place. So we have a mixture of WLAN and wireless together. Cables are connected, then wireless is there, so that some people will come in with their phone. They should be able to connect. If it is only LAN that is there, phone will not be able to connect, and tabs will not be able to connect. And there are some systems who don't have ports, and they are not having an external connector. So they use what do I call it? They use wireless to connect. And may I say this, please? In all our computer labs, as you are buying systems, make sure you buy system that comes with Ethernet port directly from the factory. Don't buy a system that you are going to use USB connector later. Don't buy that type. I am drawing my ears, I'm saying it. Did you hear my voice? Hello?
Yes, sir. Yes, sir.
Hope you hear my voice. Because the USB adapter will fail. So don't buy a system with USB adapter. Buy the system that comes with LAN port directly. So now our typical structure will look like this. A typical structure. So you have our internet, we have our router, we have our switch, which computer lab can be there, and we have access points that are also connected. This is the combination that we have in all our school system. Then we have in our LAN, we have computer labs, CBT centers, LAN, computer lab, CBT center, WLAN, staff room, classroom, offices. So we have this combination available in all our school. Now, common LAN and WLAN problems in school. Common problem. LAN issues. Loose cable, faulty switch ports. Pay attention and listen. Faulty switch ports. Network card problem. If you are using a desktop or a server, it can have a network card problem that is connected to it, where the cable is connected to. It can have issue. The switch port, the port where you are plugging the cable to can have issue, can go bad because it has metals there, it can go bad. Or the cable, the RJ45 you are using to connect the cable at both ends can be loose. So you must take note of that. Then what about wireless? Weak signal. Maybe distance is too much or too many users are there connected to a single access point. Wi-Fi password or issue of interference. What interference means is that when access points are too close to each other, if they are all on the same frequency, interference will come in. So as you are setting up access points, I will advise, as you move from class to class, you can change different frequency of the access point so that interference of access point to access point will not take place. Let it just be the interference between computers and computer that will be taking place. But between access point and access point, we should avoid that interference. Then the keys you need. First, be able to identify LAN or WLAN before you be able to troubleshoot. Know that, okay, this problem, is it a wireless problem or is it a LAN problem? Your problem could be a cable problem from the switch to the access point. Your problem could be a cable problem from the router to the switch. Your problem could be a cable problem from the switch or the router to the server. Identify what is the problem. Is it a cable problem? Is it a switch problem? Is it access point problem? Is it signal problem? Is it frequency problem? Is it interference problem? Is it password problem? Identify what it is. Then you will be able to solve it. So now, practical identification exercise. What you need to do after this. So you list all your LAN devices in all the departments, list all your WLAN devices, then you draw a simple network diagram of your school. Then identify where problem often occur and find a way, isolate that problem and get it solved. So I've sent a slide to you. This is going to be an assignment that you will submit tomorrow or we will deliberate on tomorrow. So now, WLAN issues, weak signals, too many users, Wi-Fi password is not okay, interference. So identify what that problem is. Then for your key takeaway from here now is LAN is wired, WLAN is wireless, router connects us to the internet, switches connects wired devices, access point connect Wi-Fi devices. Otherwise, school use both of them. Thank you for listening to this segment. So I give us 2 minutes break while we start the second module. So I'll stop sharing my screen. Thank you very much. Oh, can we come back now? Are we back?
Yes, we are here, sir.
Yeah.
Okay, Lagos, are you there? Lagos is not there. Abuja, are you there?
Yes, sir, we are here, sir.
Okay, Port Harcourt, are you there? Port Harcourt, are you there? Port Harcourt is not there. Uyo, are you there? Calabar, Enugu. Okay.
Yes, sir.
Owerri,
Calabar.
I know you are there. Delta is there. Benin, are you there? Abeokuta, are you there?
Yes, sir.
Okay. So we're looking at IP assignment. We'll be looking at DHCP, we'll be looking at NAT, and we'll be looking at subnetting basic. Everything we are looking at in this training are just basic. We're not going advanced. Just basic level. And I will explain them in such a way that you also be able to take off your network and troubleshoot. Take note, all our campuses that will come up to have CBT Center for WIEC, if you look at WIEC documentation, they expect each school to have network engineers on ground and technical people on ground. And in some cases, you will agree with me that the campus might want to use you. So we should have this basic knowledge, and that's why this training is holding. Then not just that. First CA, this second term, all Deeper Life High School campuses must mark my choice of word, must in capital letters. The must I'm saying is in capital letters, not small letter. Must write the exam via CBT. So at the end of the training, by Friday, you should start running. Whatever is not there, go and put it, because at the end of the exam, your first CA, you are expected to start using your CBT. So, and you start working on your network immediately. And that's why we are having this training in second week. We're trying to shift it forward. They say, no, the training must be at the time where the people are resuming so that all preparations can be made before 5th week. So, take note of what I've said. So we're looking at this module now, module 2. We're looking at IP assignment, DHCP, NAT, and subnetting. Now, the objective of this training, at the end of the training, end of this session, participants should be able to explain what an IP address is, differentiate static and dynamic IP assignment, understand how DHCP works, explain what is NAT in simple terms, then understand basic subnetting and why school needs it. Then identify IP-related network problems. If the problem is IP-related, you know how to identify it, you know how to address it. So that's why we put objective, we'll go through the training, and we'll see how to identify related problem. So can we move on now? Now, introduction to IP addresses. What's an IP address? If I ask, maybe, all of us are teachers. If I ask, Owerri, can you tell me what is an IP address? You have heard that before. Can you unmute and tell me what is an IP address?
All right, sir.
Don't look at the slide.
IP address. Yes, I'm aware. An IP address can be seen as an address that uniquely identifies a particular network.
Okay. He said an IP address is an address that uniquely identifies a particular network. Yeah, that is correct to an extent, but that is elaborate. We're not looking at it in terms of network, we're looking at it in terms of devices. So it's an address that uniquely identifies a device on a network. Now, an IP address, Internet Protocol, IP is an acronym for Internet Protocol. Address is a unique number given to each device on the network. It uniquely identifies that device. Now, I want you to think of it like this. In a street, we identify houses based on the house address. Each of us that have a GSM, a phone, we identify each person by the SIM number, the number on the SIM, the phone number. And each of us here, we also have names for identity. Why do we give names to children when they are born? Why are names given? If name were not given to me, and every one of us here, when we're born, name were not given. If I come to your campus and I have 30 teachers sitting down, if I want to call anyone, I will just say, hey. And when I say, hey, everybody will be looking at me because I'm not talking to any particular person. It means we cannot identify who did this. The same thing in a network. An IP address is like a name that the device is assigned. And with that, it is able to communicate with that network. Once it does not have that, no communication. No IP, no communication in an IP packet network. So an example of an IP, I'm not going to the nitty-gritty and the technicality of IP address because normally I'm supposed to tell you an IP address is a 32-bit address that is identified in binaries. Then it can be converted to decimal via this. I'm not going to that nitty-gritty because that is going to bring confusion at the end of the day. So, but an example is what we have on the screen here. Divided is a divided into 4 octets with numbers with dots in between each of the number. Yes, there are certain technicalities I may still mention later, but let's use this as a unique example. 192.168.1.10 is an example of an IP address. And that means this address will be assigned to a device. And no other device within that network will have this same IP. 2 devices cannot have the same IP address at the same time. Otherwise, it will create what we call conflict, IP address conflict. And 2 of them will be outside the network. Even though they are connected, 2 of them will not communicate. They'll be off. If care is not taken, they can bring down your switch. And the switch can come down. If your switch comes down, then the network is down. What do I mean by switch coming down? It's not as if you see switch that has a leg that is walking on a ladder and you see it coming down from a ladder. That's not what I mean. That means it can go off or it can begin to misbehave. So once it goes off or begins to misbehave, we mean the switch is down. And once it is down, communication will be what? Will be disrupted. And any device that is connected to that switch at that time will also go off. This is common when we assign the IP addresses in a static way. But if it is dynamic, it will not happen because the router will keep track of all the devices it has assigned IP. Next slide. Now, why IP addresses are important? Number 1, identifies devices on the network for identity's sake, and therefore allows devices to communicate. No IP, no communication. Without IP, no network or communication. I think that's simple enough to understand. The next slide. Good. Now, types of IP addresses. We have private and public IP addresses. Now, the private IP addresses are the ones we use on a local network within an office, within the lab, or within the school locally. But the public IP address is the address that allows us to have access to the internet. So on our local network, if we are talking about our CBT, everything we are looking at within our CBT space is private IP addresses, because internet is not needed for our CBT to work. So we are confined to the space of what? A local IP address. Now, we have common examples like what you have here, 192.168.x.x. These are numbers, we assign numbers to them. Or we are using 10.x.x.x. They are numbers we use every time. We have an example here, 192.168.10.25. It can be 192.168.1.1, 192.168.1.2, 190.168.1.3. Now, take note. If we assign this family of IP 192.168.10.1.10.2, it means it is the last octet that the value will be changing from device to device. All the devices connected to the network, we have the 3 octet will be the same. They will have the same value numbers. That is the 192.168.10 will be the same for everybody. But the last octet, where you have 25 here, if a device has taken 25, another device will take 26, another one will take 27, another one will take 28, another one will take 29, another one can take 40, another one can take 50, 51, 52, 50, like that. That last octet will be changing from device to device. If we are assigning the addresses ourselves, we follow the same procedure. We'll assign 192.168.10.1 as a gateway. 192.168.10.2, we assign that to our server. 192.168.10.3, you assign it to your first computer. 192.168.10.4 to the next computer in the lab. .5 to the next. .6 to the next. .7 to the next. .8 to the next. .9 to the next. .10 to the next. .11 to the next. We keep assigning that until we get to .254 and stop there, because we're on the range of a subnet of /24, class C IP addressing. Now, take note, as I was saying it, I want you to take note of this. As I was saying, .1, .2, .3 to the next. If you do that and you do not document to say, computer so have assigned .6, and you forget, you move to the next computer by it, and you assign .6 to it already, you cause problem on the network. That means you have assigned same IP addresses to 2 devices. So, as you assign, you find a best way of documenting what you have assigned. If you like, paste it on the computers. Just a minute, quickly, let me attend. So, sorry, please, did you understand what I said? Hello?
Yes, I will understand. We understand.
Is there any confusion? Okay,
Yes, sir, there is a question.
Ibadan.
Yes, sir, there is a confusion.
Okay, please, let's clear that confusion. Okay, the person who said there's a
Okay,
confusion,
sir.
speak, please.
Hello,
Yes,
sir. Can you hear me?
I can hear. Hello, talk now. I'm hearing you.
What I'm saying is that I have a question. How do we assign this IP address in a practical scenario? Because I wanted to, if we something that you can project, is it possible?
Okay, that's Ababi.
Yes, sir.
Okay, assign this IP address in a practical scenario. Okay, I will take that as the last thing to do today. We're going to assign IP addresses to our systems, to our laptops in a practical scenario. We will look at it, assigning IP addresses in Windows 10 and assigning IP addresses in Windows 11 because I think if you are not familiar with Windows 11, you might get confused. So we'll look at it practically, assigning them on our systems. Windows 10, assigning also on our system via Windows 11. That taken now. Yes, Ibadan. So let's leave that to the end of the training today. Ibadan.
Yes, sir. This is Alabi Daniel from Ibadan.
Yes, go ahead. I'm listening.
All right, sir. My question is, you were talking.
I'm not hearing. No, go closer to the mic.
All right, sir. My question is, you said there's a limit to the number of IP addresses you can create. That's the one. I want to understand.
Honestly, I didn't hear you.
Yes, sir. You said there's a limit.
Far away from the microphone.
All right, sir. You said there's a limit to the number of IP addresses that can be created. Can you hear me now, sir?
Better, I'm trying to manage. I'm managing to hear you. Are talking about limit to number of IP addresses.
Now, I want that's question one. Number two, I want more explanation on that. Then number two, you were talking about not assigning the same IP address to two devices. So, if you are on the network, is it possible that the same IP can you hear me?
Miss Bimbo, this man, you are too far away from your device.
Yeah.
The person who asked the question is too far away from the. Well, okay. Did anybody hear him from any of the centers?
No, sir. It's too far away from the system.
Ibadan, can you answer that question again because it might help us? But I got the first one was saying the limit. Actually, there's a limit. There can be a limit to the number of IPs that are assigned on a network. And that is dependent on what we call the subnet mask. There is what we call a subnet mask, which every network must have. Now, by way of identification, in every network, we need to have the IP, you need to have the gateway, you need to have the network address, you need to have the subnet mask. These four things are compulsory. If they are not there, there is no network identification. What is the IP? The IP is the identifier given to a device. What's the gateway? The gateway is assumed to be the channel or the source, the route in which traffic will pass through. So it also needs an IP address. Then what is the network address? The network address is an identifier of the entire network, all devices that will connect to the network, it is a common identifier that binds and identifies all of them. Then, what is the subnet mask? Which is also called the last thing, which is the broadcast address, is an IP address that all the devices on the network are used to receive a message from the gateway. Now, that's why I didn't want to go into those complexity, because there are some of those terms that you actually need to be vast and be deep into networking before you can understand how they work. I didn't want to go into that. So, but we can have a network where we have, say, 2 systems only connecting, 4 systems only connecting, 8 only connecting, 16 only, 32, 64, 128, 256, 512, 1024, and so on and so forth. So, can Ibadan ask that question again, the second one?
Yes, sir. Can you hear me, sir? Can you hear me, sir?
Go ahead. Go ahead.
All right, sir. The question is, you were talking about not assigning the same IP address to 2 devices. I was now thinking, is it possible that the same IP address can be assigned, but not at the same time on a network? Since the MAC address of each device is encoded, we know that the IP address is only on the network. So can the same IP address be assigned, but not at the same time? Maybe a device used the IP address, maybe left the network, but the same IP address will be assigned to another device on that network, but not at the same time.
Hello, sir.
Yes, I didn't hear him.
He said, can the same IP address be assigned to a device on the same network? Can the same IP address be assigned to, can the same IP address be assigned to a device on the network? And that same IP address also be reused on another device entirely?
No, that means you are saying, for instance, you who spoke to me now, your name is Mr. Ajala. That's what I know. Am I correct?
Yes, sir.
ICT. Then I now have another Mr. Ajala, ICT, also in Abeokuta. Am I correct? If I do that, what do you think will happen if I want to talk to Mr. Ajala?
Conflict.
Conflict. So, except I will now say Mr. Ajala ICT 1, Mr. Ajala ICT 2, then me and the two of you will have to sit down to have this understanding that anytime I say Mr. Ajala ICT 1, you know who I'm talking to, and Mr. Ajala ICT 2, you know who I'm talking to. Am I correct?
You are right, sir.
So, that conflict, because computers don't have the same intelligence we have as human. So, to avoid that, you don't put same IP address on 2 devices on the same network. No, it cannot work. IP address conflict. If that happens, the things I said before will take place. There will be conflict. Those 2 devices will not be part of the network. They will not communicate. They won't communicate with themselves. They won't communicate with anyone. They won't communicate with gateway. Or it can bring down your switch. I said it before, so you don't do it. That's why I say if you are doing static IP addressing, you must document so as to avoid this. Ibadan, did I answer your question?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
You answer our question, sir.
Mr. Lucky, you can go ahead, sir.
Okay. So next,
Hello, sir. We are not hearing you, sir.
sorry, I was muted. I didn't know. So static IP addressing, we assign it manually and it does not change. As far as nobody goes to change the network setting of that system, it will remain as long as that system exists. So that's why I use the word forever. Forever in terms of for that system. As far as that system exists, the OS has not cracked, the system has not gone bad, that IP address you assigned on it will never change if nobody goes there to change it. So you do it manually. If you have 250 systems, 300 computers in a lab and you are doing static assignment, you will go one by one from one computer to the other and assign the IP. Taking note of what we have said earlier. If one is .2, the next one have to be .3. The next one will be .4. The next one will be .5. Do not have 2 having .2. Do not have 2 having .3. Do not have 2 having .4. Do not have 2 having .5. You must take note of that. And for you to be able to achieve that, proper documentation is very, very important. It is best used for servers, for printers, and for routers. But in the scenario where we are setting up computer labs for WAEC and maybe eventually for JAM, then that comes in because that is what they said they want in their specification. Desktops and laptops, whatever you are using, then you must do static IP assignment with proper documentation. So example of an IP address 192.168.1.2. If you assign that to a system, then .1 will be the gateway. So 1 is .2, another one will be .3, another one will be .4, another one will be .5. That is static IP. Dynamic IP address, on the other hand, from what we have here, dynamic IP address is assigned automatically, dynamically. It is not controlled by you. It is controlled by the DHCP server, which in this case, our router. It means the router is the one that will issue the IP address. Now, take note of this. We say it is assigned automatically. The next, it can change. Then it's given by the DHCP, that is the server. Now, why do we say it can change? If you come in the morning and connect your system to the network, the server gives you an IP. If you disconnect and you go away and come back later in the evening. Because many people have been coming, the server is not going to reserve that IP address for you. Since you are disconnected from the network, he's seen it as it is not busy. It is not used. So another person that can come will give that IP to somebody else. So if you come back in the evening, if what you got in the morning has been used, it will give you something new that is available in the pool. So it picks the IP from the pool. From a pool, it goes to the pool, pick and give out, pick and give out, pick and give out, and it is keeping track. Just as I said, when you are signing IP document, same way the router documents by itself. It's not you that document. It documents by itself. The router keeps track of what it does. So if you are to do it manually, then you have to document. But if the router is the one handling it, the router documents. So that's why the router will not make mistake to say there is a conflict in IP address. So hope that is taken. And it is used for our laptop, student devices, and phone. Now, think about it. The phones, if you want to do static, you will have issues with our phones. So the router handles it by itself. Most of our school devices use what? Dynamic IPs. Next slide. Now, we want to look at what is DHCP. DHCP stands for Dynamic Host Configuration Protocol. That means, it actually means that hosts, what we mean by host, all our devices, all the devices connecting to the network, they are dynamically configured. They are automatically configured. So there is a protocol in the router, a set of instruction. Protocol actually stands for set of instruction. The set of instruction that comes with the router operating system that handles that automatically. So automatically gives IP addresses, subnet mask, gateway, DNS server to the devices automatically without anybody's intervention. All that is needed to connect the device to a network and for it to begin to share resources immediately is provided via the DHCP. Why DHCP is important in school? Because it saves time. It prevents IP address conflict and easy to manage many devices. At a go, many devices can just connect and begin to share resources at a go. So that's why DHCP is important. DHCP process, for simple explanation, the device, if you look at this, the device will place a request for IP, then the router will offer the IP, then the device accepts the IP, and network connection is initiated. And this happens immediately in seconds. That's why when you come to an environment and you can see that with your phone or your laptop, you touch your wireless and you see a network. The moment you click on the network and you click on connect, you see something turning around. That time, that negotiation, this process of DHCP is taking place. That negotiation is taking place. The device will send a request to the router. Say, router, I want to join your network. That means I want to share from the resources you have available. Please give me IP so that I can be part of the network. So the router picks that, gets to his pool. Once IP address are available to give from that network. Now, mark my choice of word. I'm going to say this because we had this issue in Port Harcourt. We had this issue in Warri. Our brethren from Port Harcourt and Warri are in the house now. They are listening to me and they understand what I'm saying. We had this issue. Once IP address is available in the pool, the router picks it out and issue it to the device, and the device will connect. If IP address is not available, the device keep turning, keep turning, keep turning, keep turning, keep turning, keep turning. And it will tell you, it will either say unidentified network. It will also say it cannot join this network at this time. There's nothing you will do. You can't be part of that network. You can't share resources. If students are to write exam, that child cannot take exam. It cannot, the teacher cannot connect to the internet. You can't reach anything on that network because IP was not distributed. You didn't receive an IP address. And I will tell you why it can happen. Now, DSCP example in school, the laptop joins Wi-Fi, wireless network. The router assigns him an IP address, assigns him the gateway, assigns him the DNS. Now, I need to explain when I say it picks the IP from a pool and gives out. And I make use of a word. I say, if IP is available in the pool. In Warri campus, we had this issue that when students were taking exam in the class, access points are connected to the class. But the ICT person will discover that all of a sudden, at a point, students are not able to connect. So we did a troubleshooting and we discovered that the cable that was coming from the router and going to the class somehow was also part of the cable where it was taken to the computer lab. Now, and the subnet mask that was connected from that port was /24. And a /24 subnet mask actually means you have 256 IP altogether. Out of the 256 IP altogether, one is network IP, which is the .0. One is the broadcast IP, which is the .255. And one is the gateway, which is the .1. So at the end of the day, you are only going to have 253 IPs available for distribution to devices in that network. And the school population was almost 500 or 500 and something. Why would we not have that problem? So what was happening is, the moment 253 people have received IP addresses, others will try to connect. They are not able to connect until we identify that problem. When we identify that problem, work on the network. In fact, our brother told us here that he shared testimony. Mr. Efe, please, can you unmute and tell us what happened and how you shared testimony in church?
Praise the Lord.
Hallelujah.
Mr. Efe,
Sir,
tell us your testimony.
so when the incident happened, sometimes when we are writing CBT like this, many students will not connect. So early morning that day, I had to call Pastor Loki and we resolve the problem. So with that, our students, a good number of them, we were actually even badging. That time we were even badging students. We say JSS1, we write CBT, others we write theory. So, but when the problem was solved, it was even solved almost at the end of the exam. So we did not implement everybody writing together because we're almost done. We have suffered all through. But the truth is that it has been resolved now where students cannot write and they will not be experiencing the problem of trying to connect. That's what really happened. Thank you.
Wow, human error. You now took it to the church as a testimony.
Yes, it was a very big problem. You know, when you are in soup, that's when you know the value of what God has done for you.
Very good. It was actually a very big problem. And all the while, when he was complaining, I couldn't figure it out. In fact, at a point, you know, when you have issues like that, You might even be suspecting what is not there. At the point he will say, is it a server? I will say no. Is it there? There was a day they were suspecting, is it the network, the router? So Mr. Katule was around that day. I told him, okay, log into the router. They logged into the router. I said, okay, check the CPU resources. What was used? The router was less than maybe 20%. So I say it can't be. Look at it. The percentage of the CPU is less than 20%. So there is something until that day when we connected and he was showing me some things. That's when my mind went. And I asked him this question. I said, show me, where is the cable that went to your lab? He pointed, he said, from here, say from this switch, we took to the lab. I said, okay. I said, okay, where is the cable that went to the classes? He pointed, I said, where did you connect it from? He said, from there, from the same switch. I said, we have suffered for nothing. Because the switch where he's connecting from to the lab and connecting from to the classes is connected from one port of the router. So that means the traffic is coming from that point of the router to the switch. And in fact, server was even connected to that switch at that time. So from the port of the router to the switch, then from that switch to the lab, and from that switch to the class. So all of them are sharing traffic from one port of the router. And total IP that can come from that port of the router to the devices is no more than 253. So what did we do? Immediately, the cable that is going to class, we took it from there. I told him plug it on another port, and I changed the subnet marker to /23 to give us 512. And that took care of the problem immediately. So understand what I am saying so that you don't fall into that problem. Port Harcourt had the same issue. We did that segmentation immediately. And the moment we did that segmentation immediately, in fact, their own became even more beautiful that we separated junior school from senior school. So we placed senior school on one router, we placed the senior school on another router, and the problem was solved immediately. And it came largely from what? IP addresses. So let's take note of that as we go to design and work on our network. So next slide. Is there any other question? Okay. Good. So common DHCP problem. Common DHCP problem is either the DHCP server is disabled. Number two, IP pool exhausted. That's the problem we just explained now. That is, too many devices are connected and the IP pool is exhausted. Therefore, no new device can join the network. Then, three, wrong network cable. The network cable have a problem. Or you have multiple DHCP servers. You are assigning DHCP server and you assign multiple of them to the same interface. You are going to have a problem. Now, what are the symptoms? Internet will not show or limited connectivity. Device will not be able to connect. Just like the scenario I explained from Delta campus, the devices will not be able to connect because they have not received IP from the DHCP server. Therefore, they will not be part of the network. So we must avoid that. If we have, say, we're going to look at a practical scenario shortly on how to properly address that so that we do not have this issue. Now, what is NAT? NAT simply means network address translation, and it's a situation whereby we allow many devices to share one public IP address. That's what we run in largely many networks across the world, not just in our school. Many networks, because Ordinarily, every device must have a public IP address before it can connect to the internet. If we are to do that, public IP addresses will not be enough to connect everybody to the internet. So to avoid that, that's why NAT is done, so that all private IP addresses can hide behind a single public IP address and people can still have access to the internet. So now, if we explain NAT, I'm not going to waste too much time in NAT because it's not really part of a headache like that, but it's just that we must understand what it is when we're having a training like this. So, school has one public IP that is given to us by internet service provider. Then all our devices, in hundreds of them, maybe in tens, in 20, in 50s, hundreds, all want to connect, and all should have access to the internet. So our router is the one that does the NAT. So in that case, all our PCs, our phone, our tablet, all pick IP addresses from our router. Then these IP addresses they pick are private IP addresses. Then our router has a public IP address at the back connected to it that connects it to the internet. Why is NAT important? Because it saves IP addresses. I mean public IP addresses. It saves them, provides basic security. What does that mean? It hides your local network from the internet. So the internet does not have direct access to your local network until certain firewall rules are set up. Now, it makes sharing of internet word possible. That is what NAT does for us. Now, what is subnetting on the other hand? Subnetting means dividing one network into smaller network groups. We subnet them. This small network, another small network, another small network. Each of them can have different IPs depending on the way we handle them. And each of them can come from different interfaces. Or if all the networks are coming from the single interface, it means we put them in what we call VLAN, virtual LANs. We can use VLAN to achieve that. So why schools need subnetting? Because we want to have a separate, we could decide to have a separate network for staff and a separate network for students. We can decide to have a separate network for a block and a separate network for another block. We can decide to have a separate network for a class group or another separate network for another class group for easy identification, to improve security, to reduce network congestion, and for easier troubleshooting. So we can divide our school into different network segments so that a single network segment is not too large. Simple subnet example. So we have a network of 192.168.1.0/24. Now, this /24 means 254 devices. Now, but out of these 254 devices supported, only 253 will be available for use. How? One of these IP will be taken by the gateway, the port of the router that is issuing the IPs. One will be taken. So 253 will be available. Now we can split this 192.168.1.0 into /24 into two different parts. That means /25/25. So each will now have 128, 128, 128 on this side, 128 on this side. So now 128 on this side, 128 on this side, you will remove the network address, you will remove the gateway, you will remove the subnet mask from each of them at the end of the day. So with that, we can segment that network differently. Now, looking at this diagram here, this table here in our right, school subnet example, we can decide to have different departments having different IP addresses, as I said earlier, or different class, or different halls, or different group having different IP addresses. Maybe admin have a separate IP address, 192.168.10.0/24. Staff having 192.168.20.0/24. Students 192.30.0/24. Then CBT lab 192.168.40.0/24. Each of these are different subnets. Now, on this, say you have admin with 192.168.10.0/24 as the network address. The first IP there can be 192.168.10.1. The second one will be 192.168.10.2.10.3, .10.4, .10.5, until .10.255. From 0 to 255. For staff, you can also have 192.168.20.1, .20.2, .20.3, .20.4, .20.255. For students, you can have .30.1, .30.2, .30.3, .30.4, .30.255. Then CBT lab, .40.1, .40.2, .40.3, .40.4, .40.255. Now, I'm saying this to say this. Are we not having conflict? Because I said we can have .10.1, .10.2, .10.3, and I also said .20.1, .20.2, .20.3. No conflict. Because the third octet, one is .10, the other one is .20, the other one is .30. So they are on different subnets. So whatever you have on the last does not count. But you must make sure you do not have .10.1, .10.2 in two places. Am I communicating? Do we understand what I am saying?
Yes, sir.
Hope it is clear.
Yes, sir.
Confusion.
Hope it is clear.
Yes, sir.
Is there any confusion?
Is there any confusion?
Good. So that's that with subnetting. Now, common subnetting mistakes. 1. Using same IP range for everyone. It could be too small, because that is the only way. Because if it is too large, there's no problem. Once the router issues IP addresses to all the devices available, then that will be okay. If no request comes in, no IP to issue out. Using same IP range for everyone. And then another thing is that, like what I showed us here, say admin now, we have 192.168.10.0/24 connected to ETA 4 of the router. You put this IP address on ETA 4 of the router. You now put again on ETA 5 on the router, 192.168.10. That means you have put the same IP range. As far as you have put 192.168.10 on one port of the router, you don't repeat that on another port. The third octet must be different on any other port that you want to put on the router. So you can have 192.168.10 on ETA 2 of the router, 192.168.20 on ETA 3 of the router, 192.168.30 on ETA 4 of the router, 192.168.50 on ETA 5 of the router. If your router have up to 10 interfaces, you can now have 192.168.50 on ETA 5.60 on ETA 6, like that, and so on and so forth, making sure the third octet is different from one router port to the other. If you want every port of the router to be a separate subnet, you must make sure that the IP addresses, the subnets, are all different. Hope that is understood. So that's what we mean using same IP range for every one. Then wrong subnet mask. You are using the different subnet. Then no network documentation. So do your documentation. When you do that, pick up a paper, pick up a document, and document what you have on your router. If you have a single router in the school, call it your main router, whatever name you call it, and what you have on ETA 1, ETA 2, ETA 3, ETA 4, document it and put it there so that when I come in, if I plug a cable to ETA 4 on the router and put on my system, I should know the IP range I'm expecting to receive. Now, tip, always document IP ranges. Always document. I keep telling us that always document. Always document. Then, practical exercise. Now, check IP address on your computer. Identify gateway and DNS. Identify whether IP is static or it is DHCP. Assign departments to different subnets. Draw a simple subnet diagram. This is actually what we are expected to do in terms of practical exercise. I think we're going to do it at the end of the day. We're going to do it and submit tomorrow because of time. That's why I'm trying to rush so that we don't stay too much. Now, summary and keep taking. IP address identify devices. DHCP assigns IP automatically. NAT allows internet sharing. Subnetting organizes the network. Proper IP planning improves network performance. Very, very important. This slide, everything is just summarized and precise for our assimilation. And I believe that this is actually like a master class of a basic network class. Yes.
So please, have you sent this slide? Yeah.
ICT is in the ICT platform.
Which one, sir?
The normal our ICT platform and the LHS ICT.
Okay, so when are we doing the real practical?
Oh, hey, you are going to be doing it. I'm giving you assignment.
Okay, that's the assignment, right?
Yes.
Okay, sir. Thank you.
Okay.
Well with you.
So,
Hello.
thank you for listening. Yes.
Please, can you resend that address because I want to access it, but I'm having difficulty. Let me use laptop and try it here.
Which address?
The platform, the platform address, so that I can join. And the link.
I sent it to the chat now. If you go to this Zoom.
Please, can you forward it again, please?
On the Zoom, I'm seeing it there now myself. It's there now, the chat. Go to the chat of this Zoom. Click on chat on Zoom. Click on chat and scroll up. You see it. That's the message. I think that's the first message sent today. Messages are not plenty there now. You see it. You see it from Pastor Lucky. You see chat.whatsapp. The link is there. I'm seeing it now on the chat.
Okay.
Of.
There's someone who sent the question on the WhatsApp.
How do you know?
Okay, we're ICT here.
No, you are not in a group now. On the ICT WhatsApp.
Someone has clicked on the link. So they need to acknowledge it so that
No. Are you sure?
Yes, sir. I said DLHS, I see all.
It's you. Somebody didn't click on it. I won't receive you because you are trying to dribble me. So, next module quickly because of time. And this one is a very sweet one. So bandwidth planning for our LAN, for our wireless, for last CBT session. The emphasis here is large CBT session. That's the emphasis. So the objective of this module, by the end of this session, participants should be able to understand what bandwidth means. 2, estimate bandwidth needs for CBT exams. No time. Okay, somebody is requesting for 10 minutes break, but I am not giving 10 minutes. I'm giving 5 minutes. So I will wait for you 5 minutes. I'm giving you 5 minutes break, not 10. 5 minutes, please. Okay, Calabar, I saw you raising hand. Can you ask your question?
Yes, sir. Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Yes, I say that because of the program, there's a program coming up tomorrow, and an ES will be involved and will be fully involved. SS1, SS2, SS3.
I don't know why you. I don't know
for
why.
an online class.
Hello,
So I
hello.
said, let me inform you because I don't know how we're going to switch. Because
I
we will be
don't
the
know
one
how
to set up
I
the.
don't know how. Hey, can you hear me? Hello.
Yes, I can hear you, sir.
As you are saying,
I can hear you, sir.
what is going on tomorrow doesn't need you to be in the class. Tomorrow, an online teaching will take place for SS1 for biology. Are you their biology teacher?
No, sir.
Tomorrow, online class will be going on for SS2. I think physics. Are you their physics teacher?
No, sir.
Tomorrow, an online class will be going on for SS3 chemistry. Are you their chemistry teacher?
No, sir.
Now, what is your role as ICT? One, to be sure at that time, because the timetable has been sent. I don't know whether you have it, or if you don't have it, I'll forward it. I will drop it on the ICT platform. Do you have it?
Sir, please,
Can you say it again, sir? I didn't get you, sir.
I said, do you have the timetable for?
I don't have the timetable, sir.
Okay, I will drop it on the ICT platform for all of us. Now the timetable is coming up like this: from 9 a.m. to 10 a.m. biology SS1, and is being taught from Lagos. The biology teacher will be in class to teach. All the campuses will connect. SS1 will connect. Only SS1 will connect. And the biology teacher should be in the class to monitor the class. What is the role of ICT? Is to be sure the class is connected to the Zoom. That's all. From 10:10 to 11:10, SS2 physics class. The person teaching the class will be teaching from Lagos. Same thing. Your role, your responsibility is to be sure the class is connected. The screen is there for the children to see. Same thing, 11:20 to 12:20, chemistry will be taking place, also coming from Lagos. So, I am aware this program is coming up. These programs have been scheduled long before now. And this is coming up on Wednesday. I'm aware it's coming up. Is there going to be a clash? The answer is no. Two different Zoom. You are using a different place for your ICT training where you are seated. And they are having the class directly in the class. So what's your role? In the morning, you make sure SS1, SS2, SS3 are connected. When it is 9 to 10, they connect, they have their class biology SS1, 10:10 to 11:10, SS2 will have their class, 11:20 to 12:20, chemistry will have their class. So you must make sure every facility needed for the classes to connect are provided by the school. And if you do need to talk to the principal for anything, you talk to them. Is data needed for that? You talk to them, make that arrangement. I that I'm talking to you, I'm also part of it. I will make sure the class is on, and I will assign someone to go and help me supervise. So I don't know whether you understand what I said.
Yes, I do understand, sir.
Okay. So is it possible to get it done without issues?
Well, what you said yes, what you said is possible.
It's noted, sir. Can we continue?
Yes, so that we can finish on time. So I want to send the timetable to us now. You will see it on the online class timetable, so that if your principal have not given it to you, you have a document to work with. So I've dropped it on the ICT platform.
Hello, sir.
Yeah.
Sir, you dropped this one. Thank you so much, sir.
Yeah.
Sir, please, this thing you just said now about the online teaching, sir, can't it be in the afternoon?
I don't understand.
Sir, should it be in the morning? Do you understand? So we'll be having biology.
Yes.
There so different subjects.
We cannot change the national decision here now. Let's continue our program.
No, so I'm just asking questions. It's changing anything, but I'm asking because I'm thinking it could also be in the afternoon since it's 40 minutes.
SS1 only have one period tomorrow. SS2 only have one period. SS3 only have one period.
There will be 5 different subjects.
No, their other subjects will be taught from the school.
Okay, sir.
Do you understand what I'm saying? They are not having online class throughout the day. They only have one period where test running. They only have one period tomorrow in SS1. Once they finish that class, they continue their normal timetable work in the school. Then,
Oh, yeah. What I'm saying is that you see that, let's say they're having first period 8 to 8:40 biology. Normally, like we have 5 classes, 5 hours in a class. SS1A will be offering digital technology.
Yeah, what you are saying, it is the head of curriculum that drew the timetable. That's why we say we are using it to test run. So can we go ahead now? Okay, bandwidth planning. Hello? I can't hear you.
Go ahead, sir.
Okay. Bandwidth planning, our wireless LAN for last CBT session. Now, we say the objective is for us to understand what bandwidth is, what it means, then estimate bandwidth needs for CBT exams, then plan LAN and wireless bandwidth properly, prevent slow network during CBT, and to identify and fix common CBT bandwidth challenges. That's why we are looking at this module 3. So now, if you look at the diagram here, low bandwidth, high bandwidth, if you look at a road that is 8 lane will definitely accommodate more cars than a road that is 2 lane. A road that is 2 lane, if the high traffic, if the volumes of vehicle going towards that direction is high, definitely you will meet traffic. But if that same direction, and we change the road and we make the road 8 lanes, that is 4 lanes on this side, 4 lanes on that side, you will discover that everything will flow smoothly. And that is exactly what network is also. What is bandwidth? Bandwidth is the amount of data that can pass through a network per second. It is measured in Mbps, megabits per second. Example, 10 Mbps, 50 Mbps, 100 Mbps. And that's how internet is rated. So look at an analogy here. Bandwidth is like a road. Small road will cause traffic jam. Wide road, traffic will be smooth, just as I explained to us earlier. Now, why bandwidth is critical for CBT? Now, the reason is because during CBT, many students connect at the same time, and questions will load simultaneously. Answers are submitted at the same time. Timers and autosave run continuously. It is different from when staff are browsing. Teachers are in their offices, they are browsing. This one maybe is checking the news. This one, some might be on YouTube. This one is checking. And now, if a teacher is checking the news, once he load that page that has the news, he is going to stay and be reading the news. It's different from an exam. An exam, students are watching the time and they want to finish. It could surprise you that 50 to 100 students might be submitting at the same time. And that traffic is hitting your network at the same time. So that's why for CBT, the traffic or the network wants to be have to be uninterrupted. If any interruption comes in, there'll be a problem. So bandwidth is very, very critical. Now, poor bandwidth will cause slow loading for the questions, time out, the page will time out, exam will be disrupted, and students will begin to complain. Because when the student click next, it will roll and roll and roll and roll and roll and could stay there for a long time. What do you expect? The child wants to finish. He doesn't want to fail. Complaints will come. So how do we address that? That's why we are here. Take note that in our exam, the type of traffic that we have are small data packets. Number two, the request is frequent because students are submitting on the go and the communication must be real time. The moment he submits, he gets to the server and gives you a return. Load the second question. As he submits, he gets to the server, load the next question. As he submits, gets to the server, loads the next. So in and out, there is always that constant communication between the student device and the server. That means from the student device, if you are using wireless, passes through the access point, gets to the switch, from the switch to the router, from the router to the server. Then the server takes decision based on what the student submitted. Then the programming language now sends a feedback back to the student. So though the data is small, but the response and the request is frequent, therefore it must be real time. That real time communication must be established. Note, it is not video streaming. It is not large download. So that means the CBT does not actually require huge bandwidth, even if we are connecting online. But our network infrastructure must be looked into. That's why we are here. Good. Now, if we estimate a bandwidth per student, for an average web page that our questions is between 100 kbps and 300 kbps. That's an estimation. Except if the page has diagrams. It is when diagram comes in, the size can increase. So in that case, if we take a benchmark of 300 kbps, it means if we have 100 students, if we multiply that, that means 30 mbps. So assuming you are writing the exam online, on the internet, for you not to have problem, and you have 100 students taking exam, it means they will consume up to 30 mbps. So then, if you have 200 students, you must have a 60 mbps internet traffic. If you don't have that, don't even think of an online exam. Now, rule of thumb, always add up to 30 to 50% extra for safety, so that in case there is anything, to be on the safer side. Now, in all this calculation, if we are using internet, we have this, and recommendation is what? For 70 to 100 mbps if we are having such number of students, say 150 students and above. But our exams are offline. No internet is needed. Our focus is now going to be online. So I did the first calculation and computation so that you understand if you are looking at it online. Now we're coming back home to our own model, which is offline. Now, what will not be our focus? Since we are looking at it offline. Number one, our LAN or our wireless, the throughput. If we say our LAN, our wireless, from the router to the switch and to the access point, what technology are we running? Are we running gigabit? What kind of access points do we have? And what kind of switches do we have? Number two, the CPU and the RAM that our router and our switches need to handle the concurrent sessions. I'm going to share some experiences with us from some of our campuses that will tell you that you actually need to know what kind of router to buy. You also need to know what kind of switches to buy. Like most times, even if you want to do your own design, most times when I send a design to us, you must listen to the voice of my design. Otherwise, you will have problem. Because experience have taught me, research, I've done several research on this, and experience have proven it that the design I will give you is going to be correct. So you must listen to that. Then connection tracking and switching, stability under load. When there is heavy load, is your router stable? Are the switches stable? Are the access points stable? So, and I made a statement here. I will recommend Microtix routers only. Size conservatively for CBT peak load. Everyone can connect at once. In Port Harcourt campus, a population of almost 700 and something, from the testimony after we settled the network problem, it is only few students who have issues with their laptop. They are the ones that were not able to connect. Otherwise, everybody connected and they took exam at the same time. In Delta campus, after the situation was solved, though towards the end of the exam, everybody could connect, and their population is about 500 and so. So even if you are 2,000 in your campus, once we do the right thing, the right devices are put in place, the right planning, the right configuration, following what I will tell you here, you will not have a problem. Everybody will connect at the same time and they will all take exam. So, I'm using an assumption and reality, very important. This recommendation assume offline CBT server is inside the LAN. Exam traffic is equal to the local traffic. No video streaming, which is true. And the traffic is mostly HTTP traffic that is going to our server because we enter an IP address on the browser and the browser sends an HTTP traffic to the router and the router connects to the server. So it is HTTP traffic to our CPT server. Then proper switches. And take note, they must all be gigabit. Don't go and buy fast Ethernet switch. Oh. I'm repeating, don't go and buy fast Ethernet switch. Buy gigabit switches. And our APs, access points, must be sized correctly. You're buying access point. Don't go and buy TP-Link routers. Are you hearing me? Don't go and buy TP-Link routers, D-Link routers. That's what you want to use. You will fail. So buy good access points for our LAN. Router is mainly doing IP routing, DHCP, simple queue, and firewall basic. So our recommendation is based on a Microtix. Say we are having 100 to 1,300 students. I don't think any of our campus is up to this, not to talk of above. So our recommendation, if you have a traffic of up to 300 students, you have to use this Microtix on the screen, which is, I think, about the highest now, CCR 2216. 12G 4S. What that means is this. The serial number is CCR, means cloud core router. 2216 is the number, the serial number of that router. 22 actually a serial number. 16 means 16 interfaces. And the 16 interfaces are interpreted like this: 12 and 4. 12G means 12 gigabit ports. And 4S plus means it has 4 SFP ports that can take 10 gig each. That means 40 gig on the 4S port. That's fiber, take fiber, 40 gig plus 12 gig. So if you have 40 plus 12, 52 gigabits traffic can pass through that router. And the technology is ARM. It's having 16 cores, 16 processor cores are running on it, and it comes with a minimum of 16 gig RAM. Therefore, there is no, in fact, they call it an ISP level router. So it can handle, if we combine Lagos, Abuja, Port Harcourt, Delta together in one building with proper setting, this router will handle the traffic. Will handle it. So, and it runs a modern router OS. So this is an enterprise hardware. Now, I want you to look at the summary of this table and the recommendation that is here based on student population. Do not get a router that is less than any of these. We had an issue in Uyo campus. Uyo, are you listening? Is Uyo campus here?
Yes, sir. Yes, sir.
Good. The Uyo campus was to write CBT. I think first time they are writing I think Cat 1. You now discover that I think about 30, 40 or 50 students connect, the network will freeze. And I told him, yes, it will happen, and I know. Why? They are using a router 2011 is the router they are using. Is actually that kind of router is used for a home office. An office where you have maybe less than 20, 30 people. And you are using it for a student population of almost 100 plus to 200. It cannot work. So how did we know? I told the brother, okay, log into the router. I log into the router. He checked the CPU. CPU was already at 98%. That means the resources were exhausted. It can't issue IP addressing. The CPU is peak value. So the traffic passing through it, there's no way it will be able to handle that. So in our design, take note, as we are considering this, we are not just looking at the router, we are also looking at the switches that are also connected to the router. So that's why I say, very important CBT design notes. Router alone is not enough. For large CBT, use gigabit switches. Because you may not use only the router, you may have plenty classes and you need to connect many devices. And the router ports will not be enough to do that. You need to bring in a switch. What kind of switch are you bringing in? There must be gigabit switches. Then I now said, avoid cheap 10 by 100 switches. I would prefer, let all the managed switches. 10 by 100 switches, like some of these TP-Link, D-Link switch, avoid them. Then use quality Cat6 cables. Use quality Cat6 cables. So, in number one, in looking at an important note in our design, we are looking at the router, we are looking at switches that should come in, and we are looking at the kind of switches to avoid and the kind of switches to go for. Then cables, it must be Cat6. Don't go for Cat5. Cat6 cables. Then our wireless. WLAN planning is critical. And let me sound this. If you have the model and the design is actually we are to have an access point in every class. And the maximum number of students per access point should be between 25 and 30. Do not allow it to be more than that. If you have it more than that, you'll be in trouble. You'll be in trouble. So now, if you are running VLAN, if you are running VLAN in the school, make sure we separate and segment our VLAN properly to know which one is CBT traffic, which one is VLAN. Then, if the CBT traffic is also inside VLAN, make sure they are properly labeled and well documented. Now, how do we place our server? Our server must be on the same local area network with our network. And preferably, I will always want the server to come directly from the router. So you dedicate a point for the server and an IP address is dedicated for it. Do not route CBT traffic unnecessarily. Disable NAT for internal traffic. So we must take note of all this. Now, exam hall network comparison. If you have LAN and WLAN, you discover that for LAN will be stable, but wireless will not be what? Stable. But remember, it will be easier to set up wireless, and in our school, we cannot set up LAN in the classes. Except we say, okay, we'll have a hall and we are moving the student. That will even take time. So if our wireless is properly planned, the student will sit in their class, they take their exam seamlessly without a problem. So LAN for wired, and we look at that for halls. For exam, like WAEC and Co, that's what they want. We know it is stable, we know it is fast, we know interference is less, and we know that if you have even 4,000 people connected for a well-planned LAN, there'll be no issue. Then WLAN, on the other hand, easy to deploy. Interference will come in. There'll be signal loss, there'll be congestion. But if you observe what I said here, if you put into consideration what I said here and the number of student per access point, your router is the appropriate type of router you should have in your network. From your router to your switch, and the switch is a gigabit switch, not failing. From your switch to the access point, your access point are not those cheap ones. Either you are using a unified APs or you are using microtic cap AC. Using such high-end access point, you will not have a problem. You will not have this problem. Even if problem will come in, it will be very minimal. For best practice, use LAN for CBT lab. They use WLAN only when LAN is impossible. And you know, in our classes, it is impossible to have LAN. So, WLAN bandwidth planning for CBT. Now, for key wireless WLAN limitations, access points have limits.
Hello, sir. Sorry, your screen
Yes.
is paused, sir.
You said?
Sir, your screen is paused.
Oh. Sorry. Sorry. So it's showing now, Abi?
Yes.
Can we hear?
Yes, sir.
Good. So access points have limits, and too many users will slow down the speed. So for our access point, we must make sure for it to be safe, 25 to 30 students. Don't go more than that. And we should have access points that have dual band. That is 2.4 and 5 gigahertz. So that some might be connecting to 2.4 and some are connecting to 5 gigahertz, so as to reduce the interference that takes place in our on the network. So very important for us to consider that. Then WLAN CBT example, 120 students. If you have 120 students, how many access points should you have? You shouldn't have less than 4, because we are looking at 30 students per AP. You shouldn't have less than 4. If you have, that means you have 4 classes. Each class you have an access point. So best practice, put an access point in every class. And the way it will work, from your router to your switch, from your switch to your what? Access points. Now,
Question, sir.
Yes.
Sir, please, my people wants to know if you can recommend a TP-Link that are gigabit. Is it recommendable, sir?
Now, I will say no. You know, organizations should have policies and what will I say? We should have policy. There are some organizations you go to, they will tell you, if not Cisco, nothing else come into their network. Hope you've heard that before.
Yes, sir.
Good. That's an organization policy, because they want to maintain a standard, best practice. Now, in our case, we'll be using MikroTik. We are looking at it that Cisco is on the higher side in terms of cost. MikroTik is easily affordable. And looking at the market, after Cisco, you can actually mention MikroTik. Now, TP-Link, on the other hand, is not bad, but they are not managed switches. Because there's a case where you want to manage the switch. If you use a gigabit TP-Link switch, there's no problem. What if you want to manage the switch? Then problem comes. So I will say, go for MikroTik. But for exams like centers like JAM, WAEC, if you are going for TP-Link, make sure it is gigabit. Did I answer you, sir?
Yes, sir. So, sir, for WAEC now, are you strongly recommending?
No,
that
sir.
we
No,
go for
no, sir. I'm not strongly recommending. I'm saying that because if that is what your budget recommends, but if
sir,
not,
best practice.
Best practice, let's go for MikroTik.
Thank you, sir.
Because it is a managed switch.
Just remove that strong. Just remove that strong and let's continue.
Yeah, so now bandwidth planning for our CBT. Now, LAN, advantage of LAN. Each PC has dedicated cable. So you have minimal interference and the performance can be predicted. Now, in that case, for us to have, in terms of best practice, we must use gigabit switches. Avoid damaged cables. Cable can show you Pepe. Disable background updates. For now, take note, please. Please listen to me. Take note of this. For those of us who are setting up CBT centers, you know that is one problem that Windows have. Windows can start doing update when students are taking exam. And the moment if care is not taken, the system will restart. So once you set up, please, I will recommend during exam period, disable all background updates so that children should not cry for you. And when there is a LAN, no Wi-Fi usage during CBT, because LAN is what you are put in place. So now bandwidth control. Now, why is bandwidth control very important?
Sorry, sir. Sorry, sir. I did not get what you said about no update. Is it that from the student laptop in the setting to go to that Windows update and we should each
Better,
student
yes.
should
Tell them,
deactivate?
tell them to disable update when they want to write exam.
Okay, sir.
And for the systems we have in the lab, let us disable updates. And if our center is approved for WAEC, when the exam, we can do all the system updates before the exam. When the exam starts, let us disable update. We can enable it after the exam. Is that taken?
Yes, sir. Yes, sir.
Good. So, why control bandwidth? We control bandwidth so that not one system will not consume more data from the other to ensure fairness and to avoid exam disruption. We actually,
it's only when things are critical.
hey, Delta, you are disturbing us. We actually do that from our router. We apply a policy on our router that does that. So simple bandwidth control method, which we use in our bandwidth. So we can disable video streaming and all that, block background downloads, then we apply simple queue on our router. Very, very important. Once that is done, I'm telling you, the exam will go seamless. In fact, as the person who is in charge of IT during exam, your heart will be up if you have been having issue before. But if you do this thing that I'm telling you on an exam day, you can be sleeping. Nobody will disturb you. Things will go on well and you can go to sleep. Common CBT bandwidth issues. Problems, causes. Slow loading, too many users. Disconnection, weak LAN. Timeout, insufficient bandwidth, that is for small routers. High latency when there is interference. Now, what do we mean by high latency? The page will just be turning. Maybe there's an interference in the access point, and I will suggest for campuses with many classrooms, go back again, check your access point. Then for those of us who are using MikroTik, using Cap AC, check the access point. After the mode, your mode is AP bridge. Then check your frequency, the channel width. Your channel width should not be more than 20 megahertz. Then frequency. Now, from one access point to the other, change the frequency range so as to avoid this kind of problem that we talk. If you do that, you will be happy you did it, and you will thank me at the end of the day when you are able to do that. So now, pre-CBT network checklist, very important. What is your router processor? What is the RAM and packets it can process without freezing? So go and check. Everybody here, go and check. Those of you, and take note, I'm recommending MikroTik routers on a network. So go and check. What is the processor of your router? What's the RAM? And what packet can it process? Disable auto updates on our servers. Disconnect non-CBT devices. Test our AP coverage. In the class, move around. For if an AP is at the end of the class, the student at the back, are they able to connect? What's the signal strength that it reaches there? Go to the back, go to the front, go to the back in every class. Let there be a technical staff around when exam is taken. We have adopted that model in Port Harcourt and in Delta campus, and it helped. We asked the school, the principal, to give us technical staff, not only ICT staff. Then they gave us, I think, from the non-teaching staff, from the cleaners, they gave us some staff. We trained them, and they started working with the ICT team. So they were the one helping the student. They moved from class to find out when there's a problem. And they help, because if you alone as the ICT person, you won't cope. So get some people, recruit them to join you, and moving from class to ask, are you having any problem? Is there any problem? And once such questions are asked, the exam will take place seamlessly. Practical planning exercise. So Now, what are they? What you are to do, count the number of CBT candidates. That means your student population. Decide LAN or WLAN. Take note, in our lab, we can have LAN, but in the classes, it's going to be WLAN. Calculate the bandwidth you need. That will determine the number of access points that we need. And I've helped us. I've said each class should have an access point. Then the number of access points will be decided by the number of our classes. Then you draw your CBT layout. So in our layout, from our classes straight to wherever we have our switch, and our switches must be gigabit switch from our switch to the router. Then the server is what? Also connected to the router. And it must be the kind of router that can handle your traffic. Do not say it's better you are not doing it. Oh, it's better you are not doing CBT. But for you to go and buy a router that will not be able to handle the traffic, you'll be calling me up and down. A point will reach, you call me, I'm not able to pick. So please, I'm telling you this. If you do this, I'm telling you, in fact, when this problem was solved in Warri and Port Harcourt campus, I was not receiving, in fact, I was the one calling them to ask them how far, because I was not hearing from them, and my heart was beating. And the brother, Bro Frank from Port Harcourt, will tell me, he said, no issue, things are going well. Efe will tell me, 2 days, I didn't even hear from Efe. Said things are going on well. When things are going on well, why should they call me? They were not calling me. Everything was seamless. That's what I'm saying. Let's go back and implement. Once we do the right thing, put the right device in place, right configuration, right setup, I'm telling you, there'll be no issue. Things will go on smoothly, and it shall be so. Now, summary and key takeaway. CBT needs stable, not excessive bandwidth, but stable. Always plan per student. LAN is preferred over WLAN, but in our case, we must have WLAN because we are going to use the classes. Limit users per access point. Do not share one access point for 2 classes. No. If you share it for 2 classes, based on our class population, 30, that's 60. You're on your own. I didn't send you to do that. Maximum 30. If it will go beyond that, it means except we have some classes where we have more than 30 students, maybe they are 31 or 32. That's understandable. But say I'm putting this access point in the middle between basic 7 diamond and basic 7 gold for them to share. You're on your own. I didn't tell you to do that. Limit an access point per class. Then test before exam day. Very important. Very important. Now, somebody can tell me to say, okay, what if we have 2 classes that are, we just divided the classes into 2, or population of 15. You are going to have a problem because where you are going to locate the access point, the signal is going to be weak somewhere. So, as I'm saying, best practice, let's have an access point per class. An access point per class. Let's have an access point per class. I hope you are hearing me.
Yes, sir.
Let's have an access point per class. This meeting is recorded. And if anything, I will play it for you and I will tell your principal, this is what I said. It is your man there who didn't do the right thing. An access point per class. Thank you for listening. Now, I want us to quickly go to the last slide so that we can end this training for today. The last module. Let's go to the last module straight. The last module straight. We delayed to this level because we actually didn't start the class on time. So forgive me for that. Tomorrow won't be like that. Module 4. Optimization tools for troubleshooting tools and optimization strategies for large CBT in our LAN or WAN. So
Hello,
I share my screen now. This one is going to be very fast. We're not going to waste time on this. So So by the end of this session, participants should be able to identify common CBT network problems, quickly use basic troubleshooting tools effectively, optimize LAN, WLAN performance before CBT, respond calmly and correctly during CBT disruption, reduce downtime during last CBT session. Now, if there is one thing I know how to do very well, when there are issues, I'm always calm. If you are not calm, you cause more problem. It's not because I want to ignore anybody, but because I want to think. When there are issues, you need to think so that you know how to solve the problem. So, understanding CBT network flow. Very important. What's the network flow? From access point to switch, or from students' system to the access point, from the access point to the switch, from the switch to the router, from the router to the server. Where is the problem coming from? So, how offline CBT works? Student PC is connected to local server, yes, but what are the things that are in between? From the student PC, then you have your access point. If you are using wireless, if you are using cable, you have a switch. So from PC to switch for cable. But for wireless, from PC to access point. Then from access point to the switch or the router. Then to the router and to the server. So you must know that. So student PC connects to the local CBT server and know that internet traffic is not available. Router is the one handling IP addressing in a DHCP environment. Routing is there, basic firewall are in place. So why are we not connecting? Is it an IP problem? Is it access point problem? Is it switch problem? Is it the student problem? So the traffic flow, CBT traffic flow, student PC, switch through AP, the router to the CBT server. Key point, if the server is unreachable, CBT has failed. How do we troubleshoot that? Next slide. Basic troubleshooting principles. The golden rule. Always check from the bottom up. From bottom up. Now, where is the bottom? The bottom is actually from the students, the first person. So you check. Student is not able to connect. Why? Is it the child's network card? Is it the child wireless network problem? In fact, I could do this most times. When I'm checking, I'm trying to connect to an access point, it is not going. I can set up the hotspot on my phone and connect that system to my phone. Is it connecting? Yes, it is connecting. Then I will now say, that means it is not the wireless problem from the system. What is wrong? Now, the first thing you should check power. The access point where the child is supposed to connect to, is it powered on? Is it off? The switch where the access point is tapping from, is it on? Is it off? The router, is it on? Is it off? Next, you go to cable. If that switch is on, the cable that is running from the switch to the access point, is it connected? Is the Wi-Fi signal reaching where it's supposed to reach? Are the students picking IP addresses? Is the router issuing IP addresses? Is the server on? And here I say, never panic. Never restart anything at once. Don't just go and some people will just go remove the server cable and say want to restart it. That. Wait and check and follow through. Now, is your problem a hardware problem? Is your problem a software problem? If it is a hardware problem, how will you know? Are the network cables there? All the physical tools, do you have them? Are all the network cable there? Are you testing whether the network cable is correct? Do you have a spare switch? Because at times a switch can misbehave. Our extension buses, are they okay? You have a LAN tester. So you must have a crimping tool, have spare network cables, have a spare switch, extension buses, LAN tester because they are handy. You will need them. Now, software, what do you need to do? Software or system tools. You will need to ping. You use your command line to ping. You want to check if the server is reachable, if the gateway is reachable. You check IP addresses. You check browser. You can use your Winbox. You use system resources. You check the resources on the server. We're going to be looking at that, I think, more, maybe tomorrow or thereabout. How you check the resources of your server. So it is server that is, the traffic hitting the server is too high. It is what is causing that. We need to have all these things handy. Next is checking IP assignment. Very, very important. So on the student system, we check whether the IP address that the student have is actually the IP address of the gateway that is coming. How do you do that? You open your command prompt, you run a IP config, you confirm if IP address exists. Is it on the same network as our server is? Is the gateway present, or it is an IP that you don't even know? That's why you must have the understanding of the IP address on the network. And the symptoms, common problem, if you see this IP 169.254, it means that system did not connect to the network. It means the DHCP has failed. No gateway, routing issue, maybe wrong subnet, or VLAN or configuration issue. So you must check that. Once you check that, and you are seeing an IP that does not resemble the IP of the network, note that the student has not connected. And because he has not connected, it is always going to tell you that the server is unreachable. Network timeout. So once that is fixed, then that child will be able to connect. Then question, you will ask yourself, why is this child not able to connect? If others are connecting, then you can troubleshoot that very well. Now, using ping for quick testing. You know what ping is? Ping actually sends an echo request to the device you want to ping. Ping is an acronym for Packet Internet Grouper. So it's used to send an echo message to check whether the device at the other end is available, and that device will respond to say, I am available. So once there is a problem, the first thing you should ping is ping the gateway. That is the interface of the router. The gateway is the interface of your router. You ping whether there is going to be a reply. So if we are using 192.168.10.1 as our IP family, that means our gateway will be .1. And if our server is .50 on this same network, assuming the server is .50, assuming .1 is our gateway. So what you do is that on your command prompt, you go to your command prompt and type ping spacebar 192.168.10.1 and hit enter and check what is the response. If the gateway is available, then ping the server. If the server is not reachable, it means the server is off, or a network cable connecting the server to a router is removed. Go and check it. So how do you interpret the result? If it replies, it means your network is okay. If they request timeout, it means there is a network problem. So the rule, if gateway fails, that means we have a LAN or a wireless issue. If the server fails, it means we have a server or our routing issue. That means the server is off, or the cable connecting the server to the router is not well placed, or the cable is sick. You know the cable can be sick. That's why have a spare cable that you trust. Remove it and put another one immediately, and the normal connection will come in. And this thing, you see, it can be funny. You use the network yesterday and everything works well. You come today, a cable is failing. That's what can happen. So you should have all these things handy. Then step 6, WLAN troubleshooting. Common common wireless LAN problems: weak signals, too many users per AP, interference, wrong AP placement. You know, I've said this thing over and over that should make them sync. They should sync because I've said them over and over. So you should understand it by now. Now, how do you troubleshoot that? Each of these problems that are here, step by step, WLAN fixes. Check the signal strength. If the signal is weak, move around and check. The people at the front, how many bars are they receiving? People at the back, how many are they receiving? Then, if too many users per AP, reduce users per AP, reduce the number of people that are connecting to that AP, either by increasing the number of APs or whichever way, by moving some people from one point to the other. Then, interference, you sort that by switching to 5G, if possible, or you run both. Some are on 5G, some are on 2.4. Then you can restart only the affected APs. Don't just restart everything. Then if AP is placed wrongly, reposition the AP if need be. Maybe bring it towards the middle. If it was in front and people at the back are not able to connect, bring it towards a middle of the class so that everybody can see it equally. Never restart the router first. Don't restart the router first. If you restart the router and people are trying to submit, the router is the one that should share the traffic, and you will discover that there will be time out. Maybe begin from AP to the switch and to the router. So don't restart the router first. You can only restart the router when you discover that it is freezing. Then you can do that, restart. But if we use recommended routers, I bet you they will not freeze. So LAN troubleshooting. If it is LAN, what do you do? What are the common problems? You have cables that are loose, bar switch port, damaged cable, or there is a power failure. And take note, I keep saying, if you are writing CBT, make sure you are running your devices on an inverter, the router and the server. Very important, they are on an inverter. Or then they must be gen till the end of the class so that nothing will go down. Step by step fixes for this LAN. Check your cable connection. You can use your LAN tester and check because the RJ head could be loose. Then you can change the switch. Change the switch entirely because changing the port may not be possible. Change the switch, then replace damaged cables, then check switch light. Is the switch powered on? Is there light? If there's no light, make sure it is powered on. Now, if we're having issues on the network and we are suspecting the router, how do we check? MikroTik router checks. Now, what to check in our router using our Winbox? You check the CPU usage, check the memory usage, then the interface traffic, the traffic that is passing through the interface, then the status of the DHCP server. Now, when you check CPU usage and the memory, if it is above 80%, that means the router is overloaded. So check your CPU. If the system resources is getting above 80%, it means the router is overloaded. Now, if DHCP is inactive, check your DHCP. Is it showing inactive? That means no IP is being assigned. If the interface is showing error, it means it is either a cable problem or the port is having an issue. Nobody will also be able to receive IP. So when you check this, I'm telling you, you will know and you will discover that you'll be able to write your exam without issue. Now, optimization strategy, that is what you have to check before the days of exam. Network optimization checklist. Number one, disable window updates. I've said that before. Block not non-CBT devices. Turn off Wi-Fi where LAN is in use. Use gigabit switches. Limit WLAN users per AP. For MikroTik optimization, check your queue and check whatever services that you need to disable and reduce firewall rules. If you have a lot of firewall rules on the router, reduce some of them so that they don't consume the resources of the router. Then, during CBT, when exam is going on, what are the things we need to look at? Now, if one student has an issue, or if one hall or a class has an issue, or if everyone has an issue. So the issue is segmented into three: one student, one hall, everyone. If it is one student that is having an issue, that means beautiful, every other person is connected. Others are able to connect. So you check, is it the cable or is it the Wi-Fi interface of the student? Or check, is the student placed on a static IP and therefore is not able to accept a DHCP? Check, can it ping the gateway? Can it ping the server? So you can easily isolate that single student. If it is one hall or the class, check the switch or the AP that is going to that class. Check the power that is going to that class. Check the cable that is leading to the AP of that class or the switch going to that class. Check the cable, the RJ, end to end. Are they properly connected? Check it. So find a way to isolate the problem. But if everyone has the issue, check our router, check our server, and do not panic. Do not panic. Do all those checks. Then at the end of the day, you are able to isolate what the problem is. And once the problem is discovered, then solution is at hand. So practical drill, very important for everyone. So what you simulate, a PC with no IP, a broken cable, an overloaded access point, a server unreachable. Let's start practice fixing this. So we need to simulate and find a way to practice them. Now, summary and key takeaway. Summary: offline CBT still needs stable network. Troubleshoot step by step. Use simple tools first. Optimize before exam day. Team coordination is key. Don't be quarreling at that time. If we are 2, we are 3, we are 4. Quarrel at that time is the wrong time. Important note: assign clear roles during CBT. Know who is going to be in charge of this, who is going to be in charge of that. Then keep spare equipment ready. Spare. Then do not overconfigure. Putting too much rule on your router. Block this firewall rule, this firewall rule, this firewall rule, this firewall rule. All that.
Any other thing?
All that consumes.
I want VP to.
All that consumes.
So we have meeting after.
Hello,
closing.
who is talking? Somebody is disturbing us.
That time. Yes.
Hello, Ado Ekiti.
Yes, now.
Ado Ekiti, we can hear the voice of your principal. Do not overconfigure. Documentation is critical. The CBT emergency quick guide, staff should memorize, things you should memorize. Have I checked power? Have I checked IP? Have I pinged the gateway? Have I pinged the server? Then have I fixed locally first before global? What that statement means, global. Global is not as in the whole world. That is what concerns everybody. Is it a single student that's having a problem? Is it a single class? Is it everybody? So isolate those issues like that, then fix local, then before you think of what, global. Thank you for listening. With this, we have come to the end of the training session for today. And if no question, then we can close so that you can go and have your meal. But if there are questions, then I am all ears to listen to your question. God bless you. I think I deserve a round of applause.
Thank you.
Wow. Somebody give me an applause. online.
Hello, sir.
Yes,
Hello, sir.
I can hear you.
Good afternoon, sir. From Lagos campus, sir.
You said?
From Lagos campus, Mr. Bamidele, sir.
Oh, yes, sir. Thank you, sir.
Yes, sir. You mentioned part of what I wanted to ask, sir.
Okay.
So some of the experiences we've had with this CBT, some students' laptop have various issues. I think you mentioned it because of this last presentation. Maybe
Yes.
their network is not connected properly. Sometimes cannot even know the exact problem with such student laptop.
Yeah.
So what do we do in that case? That's one.
Okay.
Yeah, then I was just going through the program and what we have for the other days. The testing platform we are going to use. I'm not sure I saw any of the program whereby we will talk about it. Maybe we'll talk about the platform in case we come. For instance, I just remember that when we're using it, sometimes questions that involve diagram, there's something you have to go and do before the diagram come up properly. So things like that. Concerning the test platform. Yes, sir.
Okay. Well, no issue because I think I will answer the question from the back, the second one. On the testing platform, we are going to use the same testing platform that you know, but this time around, it will look as if you do not know it because our brethren from Delta, Port Harcourt, and Warri can bear witness that the platform has actually changed drastically. Now, you can upload questions from MS Word, even from Word document. You upload your questions, no longer sticking to CSV. You can upload your questions from Word document. And what we have also added now is that when uploading your questions, if the question have diagram, you can upload the questions and the diagram together by you just put the link, the reference number, that is the name of the diagram, the name with the extension of the diagram. After attaching the question, then you go and select, even if the diagrams are 20, 10, 15, 20, you attach them at the same time and upload. So all the diagrams will upload together with the questions at the same time. And the students can view the diagram when they are answering their questions. As usual, the questions are randomized, and the questions now is a whole page. The moment you click on the questions, the entire page covers, and there is a script that has been written. Even when the student minimize the question, the student will be told that you are minimizing the question. You are minimizing the page. You are minimizing the page. Stay on your page. It will warn that child have been put in place. But to further even help, we've also done it in a way that you can attach theory questions. If you do not want to print questions, theory questions can be attached. Now, what issue we used to have when the theory question is attached, like got that feedback from Port Harcourt, is that when students are answering the theory question, because they can minimize the page, their e-notes are available on their system. So it encourages cheating when they are answering the theory question. So we have gone past that now. We have actually developed a browser now, which we are going to test run for the first time in the next CBT exam. The moment the children are to launch that browser, it is through that browser they have to take the exam. Once you start the exam with that browser, you cannot minimize. You can't do any other thing. You can't do any other thing until you are done and submitted before you can close the browser. So we have introduced that security. So we now have a browser that we can use that will make you can minimize that page at all. So I'm going to show us how to get that browser. In fact, I will show you how to even develop the browser by tomorrow, not today. I will show you, not today, but tomorrow, I'll show you how you get that browser. And once you launch it, you cannot leave that page until you press an escape key. It will request for a password. And the way we are doing it now, the password during an exam, if I'm making it for it to request a password from the database. So once we start exam in the morning, the first paper, you can set a password. So the password for this paper will even be different from the password for another paper. And the password for another paper will be different from this, so that students will not know the password ahead. So, and that means nobody is going to tell you that the browser closed, just close, because it won't close until you supply the password. So we have gone past that, so we have put those security in place. Now, on your first question, that what do we do when the student system is having issue? Now, first of all, if we have our CBT platform and architecture in place running well, we can boldly talk to parents to buy laptop for their children who do not have. And we can boldly tell students whose laptop are not okay to talk to their parents to replace their laptop. And another suggestion I will bring is, when the student is not able to connect, it means it is a wireless problem. You can buy an external USB wireless that can help them to connect. So those are things that will come in once we start running the model and it is running well. Like in Warri campus, if Warri or Port Harcourt campus tells their parents that, tells the student, they don't even need to tell them. The student will go back home and tell their parents that they want to change their laptop because they are writing all their exam via CBT and their laptop is having a problem. And the parents will replace the laptop immediately because they won't want their children to fail, because the system is working there. So once we start and it is working, then you will see that those things will be addressed by default. So I don't know if I answered you, Mr. Bamidele from Lagos.
Yes, sir. You have answered, sir. Yes, sir.
Okay. So, Abba.
The question I wanted to answer. Thank you so much for the lesson you have given us so far. I really enjoy it.
Okay. So that means I'm a good teacher now.
Sir, you say?
I said that means I'm a good teacher.
Yes, of course. You
are the best.
Somebody is here trying to say I don't know how to teach. Don't mind him.
No, you don't have to teach, sir.
Of course, my students say they like me. Oh, any person can just go your way. My students say they like me. Okay, dear HSPH.
Yeah.
No.
Port Harcourt. Speak louder. Go close to the microphone. We can't hear you. I was speaking.
Go ahead, sir.
Is it not the bus? I mean, the chain gets still.
Hello? The slides are there. Port Harcourt, we can't hear you. And I guess you are talking. Your hand is up. Ah. Is anybody hearing Port Harcourt? Is it me that have the problem? Oh yeah, go straight. Can you hear me?
Port Harcourt is having issue. Maybe
nobody can hear him, Abi.
Exactly.
I hope it's not only me that didn't hear him.
Mr. Frank, bad network.
Okay, Mr. Frank, can you do a voice note on WhatsApp and send it to my line now? Then I can hear it.
I just want to trouble you guys.
What did he say? Or can you chat? Okay. So with this, we've come to the end of the training for today. So can we begin the class by 9:30 tomorrow, so that before we begin the modules, I want to have a live session in the server room of Lagos campus, so as to show us some things in a practical terms. Then before we come to the module tomorrow. So thank you very much.
Thank
God
you, sir.
bless you. Bye.
Thank you, sir. God bless you.
Yeah, we'll meet tomorrow. So go through the slides, please.